So in an effort to save time looking for answers, I'm going to be doing a separate video for every problem. So this particular video focuses on problem 1. You're trying to decide if there is 0, 1, or 2 triangles for each side angle situation. So I would suggest first thing to do is to reorder the values so that the side opposite the angle is next to the angle, so that you can make a comparison between the side opposite the angle and the other side. So C represents the second number when you do the number line. It's also the hypotenuse when you are looking for on part 2, trying to decide if you have 0, 1, or 2 triangles. So the first thing to do is decide that A is greater than, the length of A is greater than the other side. And the answer here is yes. So since this is true, there's only one triangle. Because if we are making a number line, where 19 is the second number, 32 would be out to the right of it. And this again is where there is one triangle. If you're looking at the other 2 places, other 2 locations, they erase a line here. This would be where you have 0 triangles. This is where you have 1 triangle, and it's a right triangle. And this is where you have 2 triangles. So the key here is to first look at that second number to see if you're to the right of it or to the left of it. And if you're to the right, there's only 1 triangle. If you're to the left, then you have to use the sign rule to make the final decision. So problem B, already in the right order. So 25 is greater than 8, so therefore, like problem A, this is a true statement. Only 1 triangle. So again, if I was doing a number line, 8 is the second number. It's also the hypotenuse if we had to look for the other number. And 25 is out to the right of the 8. So again, 1 triangle. So problem C, rearrange the numbers. So B comes before A. And then check to see if B is greater than A. If that's true, then it means there's only 1 triangle because the numbers pass the second number, which is, in this case, is now the A value. But this is false. So we go to what we call part 2. So we are looking at to the left of the 33 to see where the 29 falls at. So to do that, we have to figure out what the A value would be if it was a right triangle. So the B value would be if it's a right triangle. So the measurement of angle B is 100. We're looking for the length of B to see where it's at. Most likely it's in the 2 triangle case because 29 is real close to 33. The hypotenuse, again, is 33. So we do the sine of 100 degrees is equal to B over 33. Cross multiply. So B is going to be equal to 32.499. So that's a very, very short distance between here and here for 2 triangles. Our number is 29, which is actually over here. So therefore, there are no triangles. Keep in mind the first region is no triangles. If it's a right triangle, it was 1. And if it's between the right triangle and the second number, there's 2 triangles. triangles. So this one here has no triangles. In problem 4, you need to rearrange. The measurement of angle B is 61 degrees, B is 32, A is 35. And first step is to see if that B is bigger than A, which is not, so it's false. So that means, in terms of our number line, where again the 35 is our second number, the 32 is going to fall to the left of the 35, so we have to figure out what the right angle measurement is for B. So, right triangle, angle B is 61. We're looking for the length of B, and the hypotenuse of this triangle is 35. That's, again, that second number. Using sine of 61 degrees equal to B over 35. Cross multiply. So B is equal to, or approximately equal to, 30.612. And the number we have is 32. So 32 is in here. So that means this one has two triangles. Because again, this is where the 0 is. This is the one triangle, it's the right triangle. And this is two triangles. The last two problems for number 1, reorder. So the measurement of angle A is 68, A is 9, C is 34. Is A bigger than C? It's false. If A was over 34, then we have one triangle. But because this is false, that means we're looking at the other possibility, which is the 9 is between 0 and 34. Most likely the 9 is going to be in the 0 triangle region. But to determine that, we have to find the value of A when it's a right triangle. So the measurement of angle A is 68. We're looking for A, and the hypotenuse, again, it's that second number, the side that's not opposite the angle. So again, sine of 68 degrees is equal to A over 34. Cross multiply. So 34 sine of 68 degrees, and A is approximately equal to 31.524. And 9 is definitely to the left of that, so there are no triangles. And then for the last one, again, they need to be ordered because A is not next to angle A. First thing to do is compare A to the C. If A is bigger than C, then that means the A value is past, in this case, past 27. It's not. So that means we need to find out what the A value would be when it's a right triangle. And if we do that, then we can figure out that we have, again, 0, 1, or 2. So the right triangle has an angle measurement of 57. We're looking for the A value when it's a right triangle, and the hypotenuse is 27. So sine of 57 degrees is equal to A over 27. Cross multiply. So 27 times the sine of 57 is 22.644. A is 25. So that means there are 2 triangles. If needed, go back and rewatch the video again. I tried to be as consistent as possible in terms of the steps. Reorder the angle on 2 sides. Make sure the side that is opposite the angle comes first. And then the second number is the side that's not opposite the angle. It's also the second number on the number line. Make a comparison to see if the side opposite is longer than the other side. If it is, that means we're in that region way to the right, 1 triangle. Otherwise, we have to use sine to figure out, are you in the 0 region, is it a right triangle, or are you in the 2 triangle region? Go ahead and move on to the next video if you need to. Again, answer key for these problems are posted in the back of the